is about ARM design philosophy. All information is from ARM System Developers Guide by Sloss, Symes, and Wright. The ARM design philosophy is tuned for portable embedded systems, and some of the parameters while considering the design for portable embedded systems are power, code density, the die on which the entire system is created, and how the instruction set is inspired from RISC but is much more than just RISC in terms of being tuned for portable systems. We'll start with the power. The portable embedded systems run on battery and they are designed to be small to reduce the power consumption to extend the battery life. Thus, ARM's design is done in such a way that it consumes minimum battery power. The next is the code density. The code density has to be high so that the performance in an embedded system is high for a processor. This is primarily due to the size restrictions, due to the small size of handheld devices like, say, mobiles, and they have limited onboard memory. The memory is a low cost device as well as slow in embedded systems, and this has to be taken into consideration for by the ARM design principle. The next is the die area. The smaller processor area is very important so that processor along with the other chips fit into the embedded device. This also leads to reduced design costs and manufacturing costs. The, the ARM processor has to have more and more functionality embedded in itself so that there is less need of different discrete chips. Thus, with a single chip solution and minimal die area, the embedded system is much more economical. In terms of high productivity, the ARM design philosophy incorporates principles like debug technology within the processor itself. This gives a chance for developers for a quick view of code execution and any issues are resolved faster. This leads to a faster time to market as well as reduced development costs. The next part is about the instruction set. The ARM's design philosophy is can be said to be inspired by RISC, but it is much more than RISC, or one can say that it is tuned to work with an embedded portable system. Thus, the total effective performance and power consumption is, is given more importance than just the raw processing speed, which is the sole aim of a RISC instruction set. The ARM's instruction set is tuned for embedded portable applications. Primarily, it has variable cycle execution. Rather than having instruction being executed in a single cycle, the instructions are designed for variable cycle execution. The load and store is tuned to operate on sequential memory. Rather than random access, if the access on memory is sequential, it leads to a faster time. The code density is also improved because the read from memory is at the start and end of the functions, and thus multiple register transfer happens from memory. There is also barrel shifter which is help which is helping to execute more complex instructions. This is a hardware component which helps the core processor to execute and pre-process one or more registers before it is executed by an instruction. It improves the core performance as well as the code density. More on terms of the instruction set is the concept of 16-bit instruction, which is called as thumb, which is available in ARM. Because of the reduced instruction set with 16 bits as compared to the 32-bit instructions, the code density is improved by around 30 to 30%. This helps in the faster execution. The conditional execution is also done only after specific conditions have been satisfied. This leads to reduced branch instructions, performance is increased, so does the code density. In terms of the enhanced instructions, there are multiple processes, operations that a processor has to execute for digital signal processing. These instructions are added as a part of ARM instruction set, and thus they support the fast 16 cross 16 bit multiplier operations. Because the instructions allow the ARM processor to perform much faster than the traditional combinations where the DSP is separate than the processor itself.